In this video, we'll be going over speed, distance, and time. And we'll be answering a question on this. So this is one of the topics that can seem really easy, but really hard questions can be asked with it. So making sure that you understand the basics along with unit conversions as well, because they'll love to add unit conversions into speed, distance, and time questions to trip you up. And we have an example of that in the question that we're going to show. So always make sure you read questions like this carefully and make sure you take your time when answering them. A snail traveling at 13.5 meters per hour went from a flower pot to the fence 5 2/5 meters away. How long in minutes did its journey take? So here we are given two different pieces of information, and we're also given what format our answer should be in. So we're given the snail's speed, which is 13.5 meters per hour, and we're given the distance, which is 5 2/5 meters. Now what they're asking us to calculate here is the time. Now if we look at the two values that we have, we can see that speed is in meters per hour and distance is in meters. However, the question asks us to give our time period in minutes, not in hours. So this is something we have to consider when solving the question. So we can take it in hours to make life easier, but you have to remember to convert it to minutes before you put your answer down, otherwise you can get it wrong. So the first step in what we're going to do is we're going to turn our mixed numbers here into improper fractions. That just gives us less numbers to deal with and it's in an easier format. So 13.5 can be written as, so we have 2 times 13, which gives us 26, plus 1, which gives us 27. So we have 27 in our numerator and 2 in our denominator. In the same way, we're going to do it for distance. So we're going to have 5 times 5, which gives us 25, plus 2, which gives us 27. So you have 27 over 5 meters as our distance. Now what we can do is we can choose to either convert our speed in meters per hour to meters per minute, or we can continue like this and find our time in hours and then calculate it and then convert it to minutes. What we're going to do is we're going to go through the slightly harder route of turning our speed into meters per hour into meters per minute. So to do that, we want to write out our values. So 27 over 2 will be our time in hours. And to convert from hours into minutes, we want to multiply by 60. But in the case of speed here, since it's per hour, we want to divide our whole thing by 60. And since it's 1 hour, we're going to have it as 1 times 60. So this can be given in any case, so you don't really need the 1 times 60, but it is a good way of writing it so you understand that it is for every 1 hour the snail travels 13.5 meters. Now what we're going to do is we're going to do fraction division, and for that we're going to do a technique that people sometimes call KFC, called keep, flip, and change. So this technique here can be really useful when doing fraction division, because you take the reciprocal of your fraction in the denominator and that can be turned into multiplication. So what we're going to do is we're going to keep our fraction in the numerator. So we're going to have 27 over 2 by itself. Next, we're going to flip our sign. We're going to flip our denominator, so we're left with 1 over 60. And now we're going to change our sign. So with the fraction, we know that it's division, and that's going to be changed to multiplication. So now we're left with 27 over 2 times 1 over 60. Now we can do cancellation method, so we can simplify by cross cancellation by dividing 27 by 3 and 60 by 3. So 27 divided by 3 gives us 9, and 60 divided by 3 gives us 20. Now if we multiply our two fractions together, we're left with 9 in our numerator over 2 times 20, which is 40. 9 over 40 is now the speed of the snail in meters per minute. So now that we found out our speed in meters per minute, it now makes it easier when we're calculating our time. So what we can use now is a formula triangle that can be used for speed, distance, and time. You can choose to either memorize this triangle or memorize the formula of speed, distance, and time and rearrange that way, but this can make life a bit easier to visualize it. So we have our three values, and what we can do with our triangle is we can cover up the things that we want to find. So we here want to find the time. So if you were to put your finger over t, you're left with d over s. So time is equal to distance divided by speed. So that's one of the equations. Now, say you wanted to calculate distance. You can put your finger over the d and you're left with s and t next to each other. And that can be distance is equal to speed times time. So it can all be useful when just putting your finger over the value that you want to find and then reading it off from there. So we have our equation for time, which is time is equal to distance divided by speed. And we can immediately substitute our values because both our distance and our speed have part of their units in meters. And we have our speed now has minutes as part of its units as well, which the question requires of us. Now we can substitute our values in. So distance we know is 27 over 5. And speed in meters per minute we know is 9 over 40. Now we can do our KFC method again. So we're going to keep our numerator fraction, so that's 27 over 5. We're going to flip our denominator fraction, so we're left with 40 over 9. And we're going to change our sign, so now it's multiplication. And now we can do more cancelling out. We can divide 27 and 9 by 9. So 9 divided by 9 is 1, and 27 divided by 9 is 3. And we can cancel out 5 and 40 by using 5. So 5 divided by 5 is 1, and 40 divided by 5 is 8. Now this leaves us with a nice simple multiplication of 3 times 8, which is 24. And this is in minutes. So this is our time. And since we've found speed in meters per minute, we know that our time found here is minutes, and we don't have to convert it to hours. You could have also calculated the time in hours, and you would have got 2 over 5 hours, and all you would have to do there is multiply by 60, and you would have got 2 times 12, which is equal to 24 as well. So the snail takes 24 minutes to complete its journey from the flower pot to the fence. Make sure you practice these types of questions, as they will always be harder. There will be lots of topics brought together to make the question hard.
As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.